Welcome back. Okay, so we have applied the wall stroke partition load. So the next load that we are going to apply will be the roof load. So we click on roof load. We click on roof load. So we click on member selection so that we can select the relevant member that will carry this load. So you click on group, then we come to roof beam. You select this. So the roof beam is highlighted. Okay, so you go back to load, then click on load definition. Now the type of load that is coming on the roof beam is called member load. So we click on that member load. Now go to our design template so that we can pick the magnitude of the load, which is 2.25. So we click on that, minus 2.25. So we click on add. We click on this. Okay, so we are done with the load definition, as we have done with the application of our load. So let's check our step. So we have finished performing load definition, that is application of load on member element. So we want to perform manual or automatic load combination now. Okay, so to perform a manual or automatic load combination, I love using manual load combination. So to do that, you come to load, then you click on manual combination. So here we have the combination type, which is ultimate limit state. So under ultimate limit state, you can now define your ultimate limit state. Okay, so you click on OK. So when you click on OK, you come to where you have structure. Under structure, you are going to have all the list of your dead load on it. So you now see that the factor for dead load is 1.335. So you click here to move everything inside. So meaning that this will be multiplied by each of these load definition. So the next one is to click on this category A. Now this category A it comprises of all the live load. Remember that our load type are in two categories. We have the dead load and the live load. So category A has to do with all the live load. So we also move this to this side and we click on apply. So when we click on apply, we come to new. We click on new. So this will now take us to a new load combination. So we click on serviceability limit state. So under serviceability limit state, you can also write serviceability limit state. Okay, so we are done with that. Then we click on OK. So go to structure. Then under structure, we have this, so we can move. Then we go to category A. So here you also move. So we click on apply. After you click on apply, you can close. So we have actually done the load, perform the load combination, which is the manual combination. Okay, so the next thing that we will do now is for us to perform measure. So we are going to perform the measure. So to do this, the first thing that we will do is for us to do our panel setting. do panel setting. So let's look at this. We do panel setting. So meaning source panel setting. So we are going to do panel setting right now. Okay. So to do that panel setting, so what we will do is for us to click on we click on okay. So we click on option of final element mesh generation. So you click on that. So when you click on that, you come to where you have panel calculation model. So you click on panel calculation model. Now we are going to consider the load takedown for two-way spanning slab. Load takedown for two-way spanning slab. Load takedown for two-way spanning slab. Now when you click on new, you will see that we have the finite element shell, we have the widening, steepening, we have the steepening diaphragm and all this. So we are not going to use this combination. So we are going to use a combination that will have the finite element that then also have the simplified trapezoidal and triangular method. So here in this other one, so we click on this and to check if that one has what we are looking for. Okay, now this one, no finite element, no. What we need finite element. We need finite element without steepening. Then we simplify this. So let's look for the one that will have that. Let's look for that one that will have that. Let's click on this one. Okay, I think this is the one that we are going to use. Yes, this one has what we are looking for. Okay, so we have seen the one that we are going to use, which is shell two ways. So for us to achieve this, what we will do now is we go to member selection, then we come to panel, then under panel we click on group, then we click here, now we have to escape this. Fine, go back here, change this to panel, then under group click on this. Fine. So when you click on this, you can now click on this. Click on the shell two ways. So when you click on shell two ways, you click on apply. So that has been applied to it. So you can close. And you can also close this. Okay, you close this. Now the next thing we will do now is for us to do our merging. So we are going to merge. So you click on merging option. Now before we click on merging option, we need to go back and select the slab again. Click on this one, click on this. So it is now highlighted. So we go to merging option. So from here, from this merging option, this place we allowed automatic selection of a merging method. Now let's look at our checklist so that you will see what we are trying to do here. So you click on selections, click on panel, click on takedown, click on apply. Yes, we have done that. Okay, so you select the panel, click on meshing option, allow automatic selection of this. Then then this is 14. Okay, allow automatic selection of meshing. Then 14 element size, allow 1 point. Then click OK. Then click on meshing local dimension. So now we come back. We come back here. So we change this to 1.0. We change this to 1.0. When you change that to 1.0, you remember that your this thing is active, that your slab panel is active. It has been highlighted, so it is active. So you just click on OK. So when you click on OK, while this thing is still active, you come to local mesh generation. Now, if you want to delete that mesh, that local mesh, you can actually delete it. But we don't want to delete it, so we will allow it to remain. So you click on local mesh generation. So the local mesh has been generated. So you can now close and close. So you can escape this now. You can escape this now. Okay. So we go back, because I have to take you through this process for you to also see. So after we have done that, next thing is just for us to perform our verification from analysis tab. Perform our verification. So we go back, perform our verification. Go back, perform our verification. So under analysis tab, so you click on verification. So you see it, computation model is out of date. So the limit, so we click on close. So what this means is that we need to run our generation of computational model. So we run this again. Okay. So we can now go back and run our verification. Okay. So there is no error, but we have a little warning. So that was not really a problem. Okay, so we have done that. We have done the verification. We have done the verification. We have done the verification. So the next step is for us to run analysis. That is analysis of model. So you click on the analysis tab, click on analysis type, click on the three dots and select this and then change. Then so we are going to follow this method judiciously. So you click here, go to analysis tab, click on analysis type. Analysis type. Okay. So from here, what we would do is that we click on these three dots. These dots. When you click on the three dots, on that dot, you come here, you click this one, press your control key, click here, click here, click here, and then click here. Then you close. So when you do that, you come to analysis, change analysis type. Change analysis type. Okay, let's go back. Let's go back. Let's go back. Let's go back. So we click here. We click here, we click here, we click here, we click here. Okay. We now select. Yes. We select. So when you select, you close. So from here, you click fine. Now, the reason why it did not respond was we didn't select anything. We did not just select anything. So you click on auxiliary. When you click on auxiliary, you click on OK. So we are done with that. We are done with that. So we go back again. We click on ultimate limit state. So when you click on ultimate limit state, you come here, click on combination, click on this one, then click this. So when you click that, you click it, then you come to analysis tab. So you now here you are going to use P delta. You're using P delta here. So you click on OK. I think in my previous video I've taken time to explain why we click on P delta, or why we are using the option of P delta. So I'm just trying to meet up with our time, so you can go back and watch the previous video. Okay, so after we have done that, we come to serviceability limit state. Come to serviceability limit state. Come to the three dots again. Click on combination. Click on this. Click on this. You close. When you close, you click on change analysis type. Change of analysis type. So you click on P delta again. You click on this. So we are done with that. We are done with that. So the next thing is for us to run our analysis, to run the calculation. So let's run the calculation. We have done everything. So we run. Okay, let's look at our checklist. Let's look at our checklist. Select ultimate, click on the three dots, change to the analysis type, click on P delta and close. Repeat the same process for sensitivity limited, perform calculation. So we are here. We are at this step 29. So you can see that the steps are much. You can see that the steps are much. So step 29, perform calculation. So we come here, we click on calculation. Okay, so the calculation is completed. So we can now close. We can close now. Here we can look at we can now look at a bending moment diagram, everything. So to see the bending moment diagram, you come to result, then you come to diagram for members. Then let me select, should be under ultimate limit state. So let me load description, load symbol. Okay, so I've hide the load symbol now. Okay, so under NTM, which has to do with the by element, which has to do with the beam, I will click on the moment. Then under parameters, I will come to label, come to differentiated, come to fill, then I will apply. So you can see that these are the bending moment diagram for your model. So these are the bending moment diagram. As you can see, this is your sucking moment. This is your sucking moment, and this is your hawking moment. This is your sucking moment. You can see from here, this is your sucking moment, which has to do with the span moment. This is your span moment. This is your span moment. You can see this is your support moment. This is also your support moment. This is your sucking moment. So this is your sucking moment also. Sucking moment. This is your sucking moment. So as you can see, it has brought out our moment. Now you can decide not to use the robot, not to perform robot design. If you don't want to use the robot design, you can simply pick this moment for each of the beam type. You pick the sucking moment, you also pick the hawking moment, and you can do your design using the Excel template. You can do your design using the Excel template, and when you do it, you can compare. Okay, so these are our shear force diagram, and sorry, these are our bending moment diagram with the magnitude of the moment for the span and for the support. So by the time you see this stand for support, hawking moment. This is a value for your hawking moment. This value for your hawking moment. This value is for your sacking moment, and this value is sacking moment. This hawking moment. So you can see this is hawking moment 33.53. These are all hawking moment. So you can also check out your reaction. You can check out your reaction. So to check out reaction, let's remove this, apply. Okay, so let's go and check our reaction. So let's check our reaction. Let's check our reaction. Parameter this. We can now apply. We can apply. Let me. Okay. So we now include the description. So you can now see the value for those reactions. So you can see this is 423. This is 392.25. So you can see the reaction for each of these column. You can see the reaction for each of these column. You can see it. You can see this is 350.35. This is 290. You can see this is 1.919. This is 153.79. So you can see. Okay, so we can. Okay, then for the shear force, so let's look at our shear force diagram. Look at this. Can apply it so you can see the shear force. These are the shear force diagram for each of these. These are the shear force diagram. So these are the shear force diagram. So one thing I love about robot structural analysis software is that it gives you a comprehensive detail of your analysis. So whether you want to use the software for your design, or maybe you just want to extract your shear force, your bending moment information, you can actually use those information to perform your manual design. Okay, so these are some of the information that you can actually use after you have successfully finished performing your analysis. So these are your shear force diagram and their respective magnitude for each of the beam. So you can see that at this point, this is the point of contraflexure. Which is at this point, shear is what? 0. This point shear is 0. So you can see where your shear is maximum. This is a point of maximum shear. This is a point of maximum shear. This is a point of maximum shear. So you can see. Okay. So you can see. So let's so you can now apply. Okay. So I think we are going to stop here because we don't want this video to be too prolonged, to be unnecessarily long. So in our next module, we will carry out the design. So we have performed the analysis now. So if all the elements, the entire structure has been analyzed So in our next model, we will do the design of each of the structural members. We will design the beams, we will design the column, and we will also perform the design for the footing. So thank you very much, and I know that you have learned something today. So thank you. See you in our next model. Bye. Okay. So let's look at our checklist and see what we have been able to cover. So we have been able to cover from step 1 to 9. So in our next step, okay, so we have been able to cover from step 1 to step 29. So in our next model, we will now look at the design of. Thank you very much. So see you then. Bye.